All right. So today we're going to be actually playing around with radicals. We kind of went over radical rules last time. Radical rules. I'm done. So this time we're going to be doing this thing where it's actually the thing I like about math, right? It's where you take the rules you learned. It's kind of like, I like to think about it as we're learning rules to a game, okay? And that's how I want you to approach this. Forget everything you've ever heard about math before. Forget about it, okay? And some of you are probably like, man, I'm there. What? Nailed it. But forget everything that you know about math, okay? The ideas that you need to get it right the first time, the idea that there are math people and there are not math people, or whatever you think math is supposed to be, throw it out the window with me right now, okay? Crumple it up. It's gone. We're starting fresh. We're going to approach it as a game. I want you to approach mathematics as a game, okay? And with games, it feels good when you get it right, but the great part about games is that you can keep trying over and over again, right? You're not supposed to win every time. That's what makes the game fun. Come across it that way. And what we're doing, what we've learned up to this point are just the rules by which we are playing, okay? We have a set of rules in which we are playing this game. Sorry, my nose itched. No nose ring. We are going to play with those rules today. We're going to get messy. We're going to have fun. We are just going to play around and try and learn these rules and play with these rules some in order to get what we want. Okay? Yeah. Let's do it. We are going to be 1A in a nutshell. Yes, we are. And I hope that this makes this a little more fun. Like, the whole point of the cosplay, right, is that you get to pretend maybe for a little bit that you're at UA. Or you get to have a little bit of silliness with something, right? Things don't have to be so serious. I always argue that in the classroom, I do math therapy. I'm just holding your hand and telling you it's going to be okay. And it is. It's not that serious. It's okay. And it's okay to learn at your own pace and all that good stuff. Okay? And this is coming from someone with a learning disability. It's okay. I'm just happy you're here. All right, let's see. How do I want to approach this today? We talked about the rules last time. So maybe we just do a little bit of warm up with some straightforward ones, and then we'll start playing around. And our end goal for all of these, our goal in today's things as we play around with them, I'll write it up here. Our goal for this game that we're playing is we want to get them in simplest form. That's going to be our end goal for everything today that we do. We're just trying to write this as simply as possible. And the benefit to writing things as simply as possible, right, is if I'm looking at a whole mesh of something, it's harder to wrap my... Okay? So let's do it. Let's start playing around with some of these. Sorry, I'm still like, my brain's like, how do we want to do this as simply as possible? Great, we'll do that one first. All right. This is the first problem we're starting with. And a radical, right? A radical is kind of like when I have my square root sign and stuff. That's a radical. So we are going to first start by rewriting this guy. Maybe I should start with a simpler one. We're going to start with a simpler one, okay? I want to start with a simpler one. So we're going to go back just a bit. Sometimes we think things through in the moment, and that's okay. But we will come back to this problem because this is a good one for simplifying. We're going to start a little slower, and that's okay. I'm not even using my eraser. I just was like, forget it, husband. I can do it myself. We're going to start here. All right? And just remember what we do these for. You can use your eraser. No. See, I got so used, my students kept stealing my eraser throughout the year, so I got so used to just erasing everything with my hand. They formed like a weird cult around my eraser. I got him back the last day. That wasn't helpful. All right, so here's how we rewrite these, okay? Our goal for these guys is when we have this fraction out here, right, is it's going to end up having one of these rooty deals. That's the technical term for them. No, it's not. This is what a radical is. This is a radical. Doesn't it look pretty radical? And here's what it's saying. We're going to take this 5, and it's going to be then to the power of 1 to the radical of 4. So we're just breaking down steps. We've got we've got 5, that goes in. We times the whatever was up here by 1, which here it's just 1. And then the 4 goes out here. All we did was rewrite this. The 5 went down. The 1, it goes to the power. The 4 is the radical. Okay? We'll do a couple like these. Just follow along. And again, if you're a little lost, that's okay because we covered these rules last time, okay? You can always go back and look at them on my YouTube. All right, then we'll take our x. I'm just going to put the x right here. X to the power of 3. We times it by the 1. 3 times 1 is 3. And then it's all to the power of 4. To the radical of 4. So this is how we would end up writing this guy out. It's just like that. That's how I write it like a radical. That simplifies it. All right, I'll give you a moment to write this guy down, and then we'll try one just like it, okay? We'll get this pattern down a little bit, and then we'll work on simplifying them. So all we did was 5 to the power of 1. The 4 goes in the radical outside. The denominator is that radical outside. X, 3 times 1 is that 3. The 4 again just went right outside. That's all we did. The 4 is not invited to the party. The 4 is like the bouncer outside, okay? He's making sure everything's safe. All right. I'm going to erase this, and we're going to try another one just like it, okay? Poor 4. Yep, the 1 we multiplied by them. You'll see more with the next one, okay? All right. We're going to do the same form. All right, we're going to try this guy. we're going to try this guy. Yes, the eraser. Here's what we do. We write out our radical, and right away you can take the bottom denominator and put it out here in the radical. Okay? Right away, that's all you do. In the same way, yep. All right, then we've got 2, and remember, anything that does not have a power to it has a secret power of 1. Right? Anything that doesn't have it has a secret power of 1. So we do 1 times 2. 1 times 2 is 2. It goes right there. Then we go to the x. Just going to put that guy down. What's 7 times 2? What is 7 times 2? Wonderful, my dears. Awesome, it's 14. There we go. That's all. That's all you did it. That wasn't that bad. So again, all we're doing, and someone says, but why? At the moment, we're just rewriting it in a different form, and then we're about to use it to simplify, okay? We're about to use it. Right now, we're just practicing the first step so that we can use that step. Just kind of a warm-up of our brain of last time, okay? So all we did, or it's hard when it's mirrored, sorry, is 2. Right away, we put that 3 outside in our radical form. Then we took the 2, we focused on that guy. 1 times 2 is 2. Then we focused on our x. 7 times 2 gave me 14. And that's how we rewrite it in our radical form. This is Algebra 1. All right, so take some time and write this down if you need to. I'm going to erase it. I'm going to give you guys a couple of them to try this time, okay? I'm going to give you guys a couple of them to try, and then we're going to bring it up just a little bit. And I haven't decided, I haven't gotten a good schedule down for my summers on when I'm going to be doing the lives for Math with Mike. Today just worked out for it. I'm going to try and get more of a schedule, but it might be just when I can, honestly, because my summer doesn't have much of a schedule. I will always be posting on my Twitter when they're going to be, so if you want to follow me there to get heads up, you can. Otherwise, I do post them on my profile on TikTok when I have them scheduled, okay? All right. I'm going to give you guys some to try, okay? You got this. Just follow the same pattern, and then we're going to bring it up a notch. Make it just a little bit harder. Same pattern. I'm going to erase this so we can get a little bit more room going, because I'm going to give you a couple to try out. All right, let's see here. We're going to do... All right, my dears, give these guys a try. Do your best on these ones, and we'll go over the answers in just a little bit. We're just rewriting them as radicals. Radical. Give it your best guess. Okay? I want everyone to give their best guess, because even if you guess and get it wrong, you are going to remember the answer so much better. Okay? Also, everybody, stop. I'm going to take a moment. I'm going to take a moment because I'm a little disappointed in the chat right now. Okay? So you're going to get the stern teacher for a little bit. It is not helpful for you to come on here and to go off on how bad math is, or if you're not getting it. Understood? That is not helpful to anyone, because all you are doing is you are making it harder for others. You are making it harder and scarier for other people. Do you understand that? And that just disappoints me a lot. Don't make life harder for other people ever. And if you're a troll who found your way into my thing, well, I can tell you for one thing certain, sitting around in this chat, at least you will be learning a little something. Because even existing in a room in which people are talking about something you don't know yet, you will still be absorbing it. So, thank you for coming and learning with me today. All right. Let's get going, shall we? But just keep that in mind. Talking yourself down and talking others down will only hurt you. All right. So, following our pattern, we're going to start by writing out our radical. Burp, burp, burp. And what number is going to go over here in my radical? What number is going to go over here in my radical? Beautiful, 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 my dears. This time it's going to be the 4. The denominator goes out here in the radical. The denominator goes out here in the radical. So it is a 4. The 3 now is what we're going to be multiplying by. Okay? The 4 goes out here in the radical. The 3 is what we're multiplying by. If you're curious as to why, again, go to my YouTube and find that video that we did last time, okay? That's where we talked about it. We're going to keep moving. So 5 to the power of 3 because there's imaginary 1 out there, right? If you don't see a number up in that space, there is always an imaginary 1. So 3 times 1 gives me that 3. Then we bring the x down, and we have 2. So 2 times 3, that gives me 6. Bam! That's how we write it as a radical. All right, let's try the next one. Write out my radical. All right, so now remember there's an imaginary 1 if nothing is written. My 5 goes outside of my radical. Burp. All right. Now I do 1 times 2. That's going to give me 2. Then we're going to do 9 times 2. So that's x to the power of 18. Bam. Nice job, my dears. I'm so proud of you. It's always so wonderful when that moment clicks, isn't it? Good job. All right, so now we're going to try this last one, right? And it might look a little harder and trickier, but don't worry. It's not that much. We're just adding an extra step, okay? So now we write our radical out. Burp, 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 da. The sound effects help. Singing always helps, okay? The 5 goes outside my radical. There it is. And now I got that imaginary 1. That 5 looks like it's seen some stuff. That 5 looks like it's having a rough day and it's surviving only on espresso drinks and maybe some leftover pizza. That's what that 5 looks like. Anyways, 1 times 4 gives me 4. Then we put that x down. 4 times 4 is 16. We put our y down. This is the only difference in all of this is we just added an extra thing, right? That's it. So we're going to do 3 times 4. And we get that 12. And that's it. Nice job. I'm so proud of you all. And even if you didn't get it and you tried, I'm still really proud of you. Because trying means that you got further than anyone else who was just sitting around. Trying means that you put yourself out there. Always remember that the difference between the master and the novice is that the master has failed more times than the novice has even tried. I'll give people a chance to write this down if you need to. And then we're gonna spice it up just a little bit, okay? Take a moment, get a little bit of water. It is easy. Hard math, I've always said this, hard math is just a bunch of easy math stacked upon each other in a trench coat trying to get into an R-rated movie. It's just parading around looking more difficult than it actually is. Because when we break down hard math into bite-sized pieces, it's really, really easy. Yep, it's a... I have the best metaphors. Oh, he's being lazy taking a nap somewhere. Yes, trig is a perfect example. Calculus is a perfect example because it's just a bunch of easy math stacked upon each other's shoulders. It's not actually very difficult. It just looks really big and hard. And if you try and eat it all at once, you'll choke and die, right? But if you cut it up into bite-sized pieces, it's just easy math. It's just parading around on top of each other's shoulders, pretending to be harder math. You don't get math yet. You don't understand yet. That doesn't mean you can't. It's okay to learn at your own pace. It's okay for things to be difficult. I'm super dyslexic. As I erase this, I'll tell you this. I have a learning disability. It makes it very hard for me to read and write. Okay? But that doesn't mean I don't read and write. I love reading and writing. It just means that I need more time and that I make more mistakes than other people do. That's not necessarily a bad thing, though, right? That's just who I am, and it's going to take me a few more tries. And maybe I have to find different ways of doing things. And that's okay. I don't have to do stuff exactly how everyone else does it. That's just fine. And if that's you with math, that's okay too. I was told by so many teachers growing up that I was never going to be successful at reading or writing. I was told that I would never go to college because I couldn't read and write at the level that they thought I needed to. I have a master's degree. You are not... I in fact, my master's, I got a 4.0 through it. I got straight A's through a master's program. When I had people growing up telling me I would never go to college. You are capable of so much more than anyone could possibly put on you. Okay? Yeah, dyslexic buddy. So you've got this. All right. Should we make this just a little bit harder today? Challenge ourselves just a bit? Let's do it. Let's challenge ourselves just a little bit. Now, to challenge ourselves just a little, no, I think we'll do... Sorry, brain thinking on how to approach this best. Yeah, no, we'll bring it to simplifying just a little bit more. And then we'll add one extra rule if we have time, okay? Okay. So we're going to bring it back to the first problem that I had. We're going to bring it back. I'm going to simplify it a little bit, though. We're going to simplify it just a little bit. We're going to bring it back to this. I want you to take a moment and write this out as a radical, okay? You're welcome, my dear. Ooh, someone already has some people have a final answer for me. I love it, I love it, I love it. Oh, you guys are so smart and beautiful. Look at you go. Now, some people, you might be looking at the chat going, how'd they get that answer? How did they get that answer? And that's okay. We're going to talk about it, okay? But I'm so proud of you. Look at you go. Some of you already knew this lesson, huh? Or maybe you just made an inference, and I think that is great. Let's talk about how they got that, okay? Beautiful. Some people wrote it out. That's okay. Follow along. We got this. So if we write it out like how we did before, right? We got my radical. And I'm writing it out with the radical, everyone who simplified it super nice, because we're going to have some examples coming up where there will be radicals left over, okay? We'll have some of our radical left over. The 3 goes out here. We've got 8. And we've got x to the 6th. All right. So now let's not lose sight of what this is saying, shall we? When I have this 3, this is really saying to me, what number can I multiply by itself 3 times to get 8? That's what this is saying. That's what this radical is saying. It's saying, how many times can I multiply the thing in here by something 3 times? How many times can I multiply something? I mean, what can I multiply by itself 3 times to get 8? Awesome. I can multiply 2. All right. I can do 2 times 2 times 2. Oh, that's a 3. I have an eraser. Thank you, husband. 2 times 2 times 2 gives me 8. Right? So if I take the radical of 3, 8 to the power of 3, that means that this gives me that. That's what that means. Because it's saying I can multiply 2 by itself 3 times to give me 8. It's the 3rd root of 8. That's what this guy's saying, right? Like before you were probably like, why are we even writing that? What is a radical? And we talked about that last time, but to bring that back, that's just saying this times this times this 3 times. Bam. So now, let's bring it to this x to the 6. Can we do anything with that? Can I multiply something together, the same thing, right? The rule is here that it has to be the same thing. Can I multiply the same thing over and over 3 times to get x to the 6th? Huh. Now, I know what you guys mean by 2, but it's not quite written right to say 2, right? Ooh, x squared. Yeah. Some people are like, yes, you can. I don't know how to type it out, though, which is fair. X squared. Beautiful, beautiful, beautiful. Right? And let me show you why it's x squared. Because what this x to the 6th is saying, right, is saying I have 6 x's times each other. Right? Never lose sight of what these things are saying. Because when worse comes to worse, if you can remember what something's saying, you can logic your way out of that paper bag. So x to the 6 is saying I have 6 x's. Well, can I break that up into 3s? Yeah, I can. Bam, bam. I now have groups of 3s. And I can rewrite those as x squared times x squared times x squared. Right? That's what I can multiply it by, the 3. So this, written by this, ends up being 2x squared. So many x's. Listen, I know it's not couth to talk about how many x's you have, but sometimes we must discuss it. Yay! Yep, it's 2 times x squared. Are we calling all the x's? No, we'll leave we're talking about them, but we won't call them. And now someone was like, but why? Let's put it this way. Would you rather I say this guy than this? Because I'd really rather have this at the end of the day, right? So when this is useful is if you need to simplify a situation, like in science, if you were taking some big things that you were measuring out and you're getting all your data together, it's best to simplify it down because this means more to me than this does, right? So simplifying something is like finding a nicer, it's getting the same information across to the person in as few words as possible, right? Now, this part right here, I want to talk about for just a moment, okay? Because this brings me to a rule that we can use, okay? I'm going to erase this stuff just because I don't want you focusing on it. Thank you, Eraserhead. I just don't want you focusing on that right now. I want you to take a moment with me and focus on this guy. How I said, oh, well, my 6 x's, I can write those all out, and I can break those into groups of 3, right? To figure out what this can be. Does anyone see what operation I did there that might make this easier so I don't have to write it out a bunch? Does anyone see something that I did that would make this a lot easier so I could just look at, oh, x to the 6 and the 3 and get x squared? 6 and 3. What can I do with those to get the 2? Oh, snap. Is that a connection being made? Badach! I almost like whipped off my bracelet. I moved my hand so fast. We're dividing. We took this guy and we just cut him up. We divided him up into 3 groups. Now, I couldn't do that with my 8, unfortunately, right? I couldn't do it with the 8. The 8 might take more work. The 8 might take a calculator some of the time, right? If I don't know that fact off the top of my head. But I can do that. I can do that 6 all day long, right? I can do this divided by the 3 to get the 2. And that's how you know that it can be simplified. Simplified. Because if I can divide these, I can simplify it. Isn't that nice? That's kind of nice. Kind of nice. We'll practice that guy out, okay? So I'll give you a moment if you need to get that down or if we're just thinking about it a little bit. All right. So let's try that out again, okay? Let's practice that. And I'm making these up in my head as we go, right? So I'll do my best. Ugh. Sorry if I make a little bit of a mistake. Let's see here. I want to do... work this a little... I'm going to work this backwards to get it. We'll do... we'll mix it up a little. We'll do that. We're going to just do these, and then I'm going to take the same problem, and we're going to do something else, okay? Try this guy really quick. Then we're going to change this problem up just a minute, in a minute, and do it a little different, okay? Nice job, my dear. Some of us are getting it. Oh, thank you for the heart, my love. Oh, just ignore the trolls, my dear. They're accidentally learning math while they sit here. So at least they're getting that. Yeah, it's okay to come in late. I'll be posting this later, okay? Take a moment, try this guy out, get as far as you can, okay? Oh, I'm so proud of you. Well, I'm glad you're here anyways. That makes my heart happy. All right, let's do it. All right, so the first step, we're going to write it as a radical, okay? Radical. That's pretty radical. Oh my gosh. All right, so I've got the y first. Tell me why. Hey, I'll stop. 5 times 3. The 2 goes out here. 5 times 3 is 15. I messed up. I didn't want to do that. I'm going to take it back. I'm so sorry. I'm changing the problem on you mid-thing because that's not what I wanted. This is going to be a 6. Because it's not going to reduce nicely. I want a 6. I'm so sorry. Let's wind that on back. My bad. So sorry. Like I said, making these up in my brain as I go. All right. If we do 6 times 3 instead, oh my gosh, thank you for the glasses. Oh, if we do the 6 instead, it's going to be 3 times 6, which is 18. You'll see why I needed that, and maybe some of you already picked up on why I needed that. Yeah? Yeah. All right. X to the 4th. X to the 4th, 4 times 3 is going to give me 12. Awesome. I want it that way. I love that we've got some Backstreet Boys in here. Backstreet Boy fans, I should say. Maybe we have the Backstreet Boys. I don't know. I don't know your life. Wouldn't that be something? It was because it was 15. I wanted it to be even so that it was a nice problem for y'all, right? That's why. But I messed up. That's life, right? We all make mistakes. Look at me. I'm not perfect over here. All right. So, now, what do we do? How can we get it really nice and easy? What can we do? What makes it nice and easy? Oh, you guys, Thank you, my dear. Not dividing by 3. Good guess. That was a very good guess. We're going to divide. What are we going to divide by? Like trying to stay out of the way of the problem. Yeah, we're going to divide by 2. I understand why someone said 3. I understand why someone says 6. But it's going to be 2. It's going to be what's outside the radical here, okay? This is what we divide by for these guys. So, 18 divided by 2. That's going to give me y to the 9th. And x, the 12 divided by 2, that is going to give me 6. I had a hot moment where I forgot what that was. It's 6. And that's it in its simplest form. Bam, that'd be our answer. This is just this. Crazy. It's like our mathematics is also wearing a cosplay. That was a terrible metaphor, but I'm going with it. It's just dressing up. I don't know, but that's pretty mathematical of you. When math is in other forms, it's just wearing cosplay. The numbers are just dressing themselves up. It's the same thing in a different form. What am I doing to the school system? People are gonna, you're all gonna show up and be like, the math is just in cosplay. And your teacher's gonna be like, what the actual hell? Math is my gender in a nutshell. Math is my gender. Okay, new gender just dropped. Nice. I'm here for it. Oh my gosh, my dears, look at the time. Time flies when you're doing math. But there's one more thing I want to talk about really, really quick, okay? The math is mathing. Heck yeah. Math is a gender. I mean, sometimes it's so confusing, but when you figure it out for even a moment, it's kind of nice. And then it goes back to confusing. But, isn't that the struggle? Oh my gosh. New gender just dropped. Mathematics. Excellent. All right, I want to mix this one up just a little bit more. Burp, burp. And then we're going to get going for the day. Okay, my dear? So one more. Yeah, that's what I want to do. Just thinking it through in my brains. Let's try this guy. I want you guys to give it a try. Do your best. I don't assign homework, but if you want to go and look at the rest of my videos on mathematics on YouTube, you can. I like that you guys are asking for homework. Oh, if anyone there's this. If anyone wants to follow along in the pattern in which I'm going through these, this is the book that I'm using to just guide. Like, I'm making a lot of this stuff up. That sounds weird. The lessons up, but this is the order of lessons I am going through. And this is available. I got this off of Amazon. It was only like $10. And I wanted to do that in case anyone wanted extra problems. So it's pretty affordable. So that is what I'm following along with. Okay? If that is helpful for anyone. All right. Let's do this. I'm seeing a lot of great answers. You sound like Denya Ida. Will there be homework? All right, we're going to start by writing it as a radical, right? One step at a time. You're the only teacher you want homework from? Oh, my homework is to do something nice for yourself. All right. We write the 2 outside. 2, you go outside. Radical. All right. 2 to the power of 3. Right? Because there's that imaginary 1. And now x10. 10 times 3 is 30. Why'd I write a 10? Where is my mind? Bam. All right. Here's where things get a little tricky, okay? Here's where it gets a little tricky. Let's take a moment. What is 2 to the power of... 2 to the power of 3. Who can tell me what 2 to the power of 3 is? 2 to the power of 3. Beautiful, beautiful, my dears. It is 8. Okay. I can write that as 8. All right. Here's the question. Can I take the square root of 8? Can I take the square root of 8 as is? And like nicely do it? No. No, I can't nicely do it, right? Not cleanly. That's a good way of putting it. I can't do it nicely. I can't do all of it. So here's what we can do, right? Because I do want to get this as simple as possible. I want to better understand what this is saying. I want to like get it out of cosplay. So let's write it this way. I can technically write this like this. I can split this up into 2 radicals. That's allowed. This is allowed, right? They're just multiplied by each other. That's allowed. We know what this guy's going to be, right? We're not going to leave the 8 alone. Sometimes we will have to leave the number alone. Sometimes we will. The 8 we can do a little bit more with. So this one I know. This is x to the 15. A lot of you already said that. But now I've got to figure out what to do with this guy. And here's my question. Can I break 8 up into 2 factors where I can take the square root of one of them? Can I divide 8 up? And remember, a factor is just 2 numbers that multiply together to give you 8. Awesome. 4 is 4. I can take the square root of 4, right? I can take the square root of 4. Someone is saying 2 times 2 times 2. That would work if this was a 3 out here, but it's a 2. So I want something times itself. So I can break this guy up into this. I'm running out of room, sorry. Square root of 2 and the square root of 4, right? Because 2 times 4 gives me 8. All I did there was just write it in a different way. This is where I said sometimes we're just playing around with mathematics, right? I'm just playing around. 4 times 4 gives me 16, so that doesn't work. But this 4, what's the square root of 4? Beautiful, beautiful, beautiful. It's 2. So I can rewrite this dude as 2. So if I want to rewrite this whole thing, I can do 2. And I can't take the square root of 2. I just can't do it. 2 is a prime number. All I can do to multiply to get 2 is 2 times 1. So like that's just never going to work. So I can do 2 square root of 2 times x to the 15th. And that would be as simply as I could write it. That is as simply as I could write it. Sometimes we can't simplify this 8. Sometimes we can't simplify the number in here, and we would just rewrite it along with this. Sometimes we can. And sometimes we can split it up and simplify part of it. And how do you know that this is what you're supposed to do with this? The honest answer is you just have to play around with it. You just have to play around with it. You'd get better at seeing it the more you play around with it. But it's honestly just playing around with it. Seeing what you can do. And being okay being wrong. So remember, always be okay being wrong in math. Always be okay trying something. You're not going to get it